Since the year dot, humans have wondered about, pondered upon, and come to strange conclusions concerning the big questions. Amateur speculations giving way to the professional punditry of philosopher and theologian, and increasingly of scientist. In the next 6 programs, the whys and wherefores of the cosmos, its beginning, your choice of endings, and where, if at all, humans fit in. Meet Paul Davies, Professor of Natural Philosophy at the University of Adelaide. I know this is just a large lump of Australia and not really the Dead Sea down there, but you can't help but wonder why the great desert faiths were the most conducive to science. Have you ever thought about that one?
I don't know what it is really. It must be something about the starkness of the landscape, the immediacy of nature, I suppose, the clarity of the sky.
Good view of the sky.
And the loneliness, the isolation. Gives you time to think.
With all the great creation myths, and you must have studied a plethora of them by now, do any of them in any way vaguely accord with what science now tells us?
Only in the broadest sense. The monotheistic religions all have the notion that the universe did have a beginning at a finite time in the past. And I believe that science supports that point of view. The other thing that is important about them is that not everything got created at once. It wasn't a matter of, hey, presto, suddenly here it all was, all intact. It was a sequence of steps. So to that extent, it parallels the modern scientific picture, but I don't think we should read anything deep into that.
Well, people try to do that desperately.
Well, they do, and I think this is entirely misconceived. I think there's no reason to suppose that the people that wrote these ancient texts had anything like a scientific view of the world. So to the extent we find parallels, they're interesting, but I don't think they point to some sort of deep revelatory knowledge about the universe.
Okay, taking your point about deserts and prophecy, it's still a paradox that only the Hindus seem to have a concept of deep time.
Yes, yes. I suppose that the Hindu religion is in some ways actually overdoing it, because the biggest of the Hindu cycles, I think, is much, much longer than the supposed age of the universe according to modern cosmology. But you're quite right. I think the essence of the 3, what we might call Western religions, Judaism, Islam and Christianity, is that they had not only the universe coming into being at some particular moment, but a linear time, a unidirectional sequence of events, a beginning, a middle and an end. There's a cosmic story to tell.
Nonetheless, it's only latter-day prophets that have really come up with the Big Bang as opposed to a creation.
That's right. The mechanism of the coming into being of the universe, as discussed in modern science, is actually much more profound than that in the Bible, because it's not just a matter of order out of chaos, not just a matter of imposing some sort of organisation or structure upon a previous incoherent state, but literally the coming into being of all physical things from nothing.
It's an irony, isn't it, that the term Big Bang was originally a pejorative, a joke by Fred Hoyle, who wouldn't have a bar of it.
That's right. The basis of the Big Bang theory is Einstein's general theory of relativity, and that goes back to 1915. But it wasn't until the 1920s, when Edwin Hubble discovered that the universe was expanding, that anybody really thought that there was anything like an abrupt beginning where everything was very compressed and flying out of some sort of...
But there were people who anticipated the singularity before the experimental evidence, weren't there?
Yes, curious enough, there was a Russian meteorologist, Alexander Friedman, who in 1921 took Einstein's equations from his general theory of relativity, which is really a theory of gravitation in space and time, and solved them to produce what we would now regard as a pretty good fit to the cosmological data, describing a universe that comes into being at some finite moment in the past with a gigantic explosive outburst and goes on expanding but at a diminishing rate. And he sent these solutions of Einstein's equations to Einstein himself, but the great man wasn't terribly impressed. He noted them and thought they were interesting and shrugged them aside. And it was another 10 years before, on a visit to the United States, he met Edwin Hubble and was told that the universe is expanding, and then he began to take the idea seriously, but so did everybody else. So it was in the 1930s that what we presently understand as the basic idea of the Big Bang began to be discussed seriously, but it had to wait till after the Second World War, and in particular George Gamow, promoting the idea that if the universe did originate in some sort of highly compressed state with an explosive outburst, that this may have left some sort of imprint in the universe in the way of heat radiation left over from the Big Bang and maybe nuclear processes. And it was Fred Hoyle, you see, the arch opponent of the Big Bang theory, he with his steady state theory of the universe. It's a universe without a beginning. He derisively called this sudden outburst theory the Big Bang theory, and of course the name stuck. Curious little aside, I learnt on my travels recently that there'd been a sort of straw poll among astronomers in the United States to come up with a better term than the Big Bang theory. And after all the suggestions were sent in, they added up the scores and decided that the best description was in fact the Big Bang theory.
Look, the deep waters have receded behind us, but I'm now going to get into them with you, because it seems to me that once upon a time we asked of our priests and our wise men to explain all this, and they gave us some nice little metaphors and myths, but they had the virtue, the great virtue, of being vaguely understandable. The trouble with your stuff, Paul, is that it is immensely difficult for the ordinary punter like me to get the neurons around, because you're about to tell me, as I understand, that the Big Bang occurs out of nothing, and it occurs in a context where there is no time and space. Now you can tell me that till the cows come home and are indeed fossilised, and I will find it impossible to come to terms with.
It's true that many of the concepts of modern physics and cosmology are counterintuitive. They seem to defy common sense, but in particular, they're very, very hard to visualize. A lot of people get worried about that. They think if they can't imagine it in their mind's eye, then somehow they don't understand it, or that it must be wrong. I don't think that's true. The whole power of science is that it can take us into territories where common sense and intuition fail us, and yet still lead us in the direction of reliable knowledge.
Well, we've got time to come back to this in the next 6 programs. So let's now dwell on this extraordinary instant where time begins.
Yes. So this Big Bang then is more than just the explosion of a lump of something in a pre-existing void. A lot of people, I think, have that misconception. They imagine something like a huge empty space with a sort of cosmic egg sitting in the middle for all eternity, just sitting there, and then bang, the whole thing flies apart and all the fragments go shooting off, and that our galaxy, for example, is one of these fragments. Well, it's wrong, wrong, wrong. That is not the way to think of the way that the universe behaves. We know it's expanding. We know that the galaxies are retreating from us and from each other. The whole system is getting bigger and bigger. The best way to envisage this is it's not that the galaxies are all rushing away from a common centre, because they're not. What's happening is that the space between the galaxies is swelling or stretching.
A bit like points on a balloon skin.
That's right. If you were to inflate the balloon and imagine little dots on the surface of the balloon, each dot would move away from every other dot. Now, when you use that analogy, people immediately jump to the wrong conclusion that somehow the universe is the volume within the balloon. It's not. We're using the analogy of a two-dimensional elastic surface to represent the 3 dimensions of our universe. And so we have this expanding universe. We know that the galaxies are all moving apart, and we know that, incidentally, because when you study the light from distant galaxies, it's systematically shifted towards the red end of the spectrum.
This is Mr. Hubble's contribution, isn't it, to
the famous redshift. This is how Hubble did it. He arrived at this monumental conclusion in the late 1920s that the universe is expanding because he noticed that the galaxies that were further away had redder light, and he interpreted this in terms of the stretching or elongation of the light waves. We would now think of a better way, that as the light travels through the swelling space, the stretching space between the distant galaxy and ourselves, its own waves get stretched, and that means the waves arrive at Earth a little bit longer than they were when they left the distant galaxy, and so they're redder. So that's how we know that the universe is expanding. Coming back to this idea of the origin of time, the best way I can try to visualize it is imagine now the balloon that shrinks down and down and down until it's just a little dot in the middle. All of the fabric of the balloon is gone, and at that point it just disappears. Now play this in reverse, and this represents the coming into being of our universe from nothing, with space appearing. So it's not an explosion in a pre-existing space. Space itself appears, and so does time, because Einstein taught us that space and time are intimately interwoven, and where one goes, the other shall go. And if space comes into existence abruptly, time comes into existence abruptly. So this means that there was no time before the Big Bang. This is an absolutely fundamental point. People often ask what happened before the Big Bang or what caused the
Paul,
Big Bang.
you can't blame them, can you?
No, it's a very
Given the way
natural
we're
question.
wired, this is
very natural question. Cause and effect. You go back. There's a causal chain. You push it further and further back. You get back to some point that we call the Big Bang, and you naturally want to say, well, what made the Big Bang go bang? What caused it? What was there before it? And the scientific answer is nothing. And by nothing, I don't mean empty space. I mean no matter, no energy, no space, and no time. There simply was no before for anything to happen in. Time itself began with the Big Bang.
Paul, I know we're going to try and quarantine discussions about God to the final episode, but it seems appropriate to introduce your old pal Augustine here, your favourite theologian, because didn't he have a glimmering of the notion of time beginning in this way?
Yes, Augustine had two brilliant insights, I think, into the nature of time. One of them is that we all know what time is until somebody asks us, and then we're lost for words. That's very good, I think. But the other is the idea that the universe itself came into being with time. In fact, the way he expressed it was that the world was made with time and not in time. So he recognized that time itself was part of the physical universe. And so if the physical universe was going to be created by God, then God had better create time too. This was partly in response to the old problem about what was God doing before she created the universe. And the standard answer was busy creating hell for the likes of you. So he came up with this notion that time itself must have begun with the physical world. Now it wasn't until the time of Einstein and his theory of relativity that it was placed on a firm scientific footing, that time is part of the physical universe. Time, space and matter are all part and parcel of the physical universe, and therefore the origin of the universe must include the origin of time as well. So although the idea is very, very hard to wrap your imagination around, it's 1,500 years old. Augustine was already there in the 5th century with the concept.
Let's ask you for other evidence for the truth of the Big Bang, other solid evidence.
Yes, if it was just based on the expansion of the universe alone, I think we would be right to be sceptical. But there are other strands of evidence as well, really rather powerful. Perhaps the most important of these was the discovery in the 1960s that the entire universe is full of heat radiation. It's rather like living in a gigantic microwave oven. Wherever you look in the sky, there's this heat radiation, these microwaves, with a temperature of about 3 degrees above absolute zero. So it's not very hot. It's not going to do any harm, but it's very noticeable. And it's almost impossible to explain where this radiation has come from, other than supposing that it represents the primeval heat, the heat radiation there at the beginning as part
sort
of
of
the
detritus
explosion itself.
for the detonation.
Well, the fading, the afterglow. I was a student in the mid-60s, and I can well remember the professor in my department giving a lecture about cosmology, talking about the origin of the universe, and saying that on the basis of the discovery, this recent discovery of this heat radiation, it was possible to reconstruct the physics of events that took place in the first 3 minutes after the Big Bang. And everyone fell about laughing because they thought it was so audacious that science should attempt to tackle what went on in the first few minutes. Yet now this is standard textbook stuff.
Not only textbook stuff, but also to some extent reproducible in laboratories.
That's right. This is, I think, a very important point that a lot of people don't realise, because we're dealing here with huge numbers, extreme conditions, and it all seems sort of so way beyond human experience that there's no way we could ever test those ideas, but that's not true. For example, at 1 second after the Big Bang, the temperature of the universe would have been about 10 billion degrees. Now that sounds like an awfully high temperature, but it's well within the capability of our laboratories. In fact, using particle accelerator machines, now these are huge ring-shaped machines
That governments will no longer pay for.
Governments will no longer pay for, at least not the biggest that we would like. they accelerate particles like electrons and positrons and protons and so on around and around these tubes and then smash them together. And they can do this with energies that directly recreate the conditions that would have prevailed not just 1 second after the Big Bang, but a trillionth of a second. Now, what that means is we can go some way to modelling the nuclear and particle physics processes that would have occurred in the first few seconds and minutes and see if there's any relic or trace left in the universe today that can confirm those ideas. And remarkably enough, there is. The element helium, which was first discovered in the Sun, is of course a familiar element now in the universe. It's rather rare on Earth, but it turns out that about 25% of the universe is made of helium. And pretty well all of the rest of it's made of hydrogen. And the stuff that you and I are made of, the carbon and the oxygen and the nitrogen and those things, are really like tiny impurities. So that the universe is overwhelmingly hydrogen with about a quarter helium. And this ratio of hydrogen to helium is something that is very nicely explained by reconstructing the nuclear processes that occurred in this primeval furnace in about the first 3 minutes.
Well, what about the rest of the roll call? What about the inventory of elements?
Oh, this is a fascinating one because the stuff of our bodies, say the carbon and the oxygen and so on, wasn't there at the beginning. It wasn't coughed out of the Big Bang. It was manufactured inside stars. Heavy stars manufacture these heavier elements, and heavy stars don't live very long, and they end their days spectacularly by blowing themselves to bits in explosions called supernovae, and they spew all this stuff around the universe. So when the next generation of stars and maybe planets forms, it scoops up some of these heavier elements. So in a very real sense, you and I are made of stardust.
May this pile of impurities ask you this. It isn't game, set and match for the theory in the sense that there are still a lot of rather large details to be hammered out, aren't there? There are still faint anomalies. There's even a dispute about the age of the universe.
Yes. It would be very surprising if a simple model like this explained everything in one go, just like that. I think the fact of the Big Bang, the fact that the universe began abruptly at some finite moment in the past, is thoroughly established. There are very few scientists, very few cosmologists who would dispute that. But there are arguments over the precise details, and in particular, you mentioned one, the age of the universe. This is a very old problem, in fact. It goes right back to the time of Hubble's early measurements. Hubble, of course, measured the rate at which the universe is expanding, how fast it's getting bigger and bigger. And by playing the great cosmic movie backwards, you can get some idea of when everything was all together, when the Big Bang would have occurred. Now, of course, if the universe expanded at the same rate for all time, that would be a trivial calculation to do. And if you just sort of take Hubble's figures and make that assumption, you come up with an age of about 1.8 billion years. Well, that's clearly not right, because we know the Earth, these rocks here, 4.5 billion years old. That's the age of the substance that the Earth is made of. So clearly that the universe has got to be at least that age. And astronomers using more careful measurements, looking at ancient stars in globular clusters, can push back the ages of the oldest stars to 14 or 15 billion years. Since that time, astronomers have tended to revise upwards and upwards the age of the universe, and for a long while there was a sort of uneasy truce in which it was accepted that with a little bit of fudging and fitting, you could just about get the oldest stars in the universe to fit into the age of the universe. But this has all come apart at the seams recently. The Hubble Space Telescope is able to give us much more accurate measurements of the rate at which the universe is expanding. And again, if you take a simple model, you can convert that rate into an age of the universe, and the figure comes out to be about sort of 8, 9, 10 billion years. Far too short to accommodate those stars. Now, it's not all hopeless, I might say, because the assumption that is made is that the universe began explosively, so everything was rushing apart very fast, but as time went on, the rate of expansion diminished, and it diminished for a very simple reason, that in cosmology, the only force in town is gravitation. Gravitation, that's a pulling force, you see. When you drop the stone, it's pulled towards the Earth. Well, the stars pull on each other, just as the sun pulls on the Earth. The sun attracts other stars, the galaxies attract each other, everything in the universe attracts everything
And that takes the foot off the accelerator, in effect.
That's right. So we have this explosive beginning with the universe expanding very rapidly, but gravity dragging it back, causing the universe to decelerate, the rate of expansion to slow. So it's like a braking effect. So if you measure the rate of expansion of the universe today, which is what they've done with the Hubble Space Telescope, for example, you can't convert that into an age of the universe unless you know the rate of this braking effect. And the amount of braking there is depends upon the amount of matter in the universe, and that's a big mystery.
Well, you've got dark matter coming into that equation.
That's the point, that if what you see is what you get, then you come up with one age. But if there's a lot of unseen matter, a lot of dark matter or a lot of inconspicuous matter, then there'll be more braking, and you come up with a shorter age. And of course, we don't know how much dark matter there is. We know there's a certain amount. There's very good evidence, for example, in the way the stars move around our Milky Way galaxy, that there's unseen matter accelerating them. They're moving far too fast. If the only matter in the galaxy was the visible matter, what glows, the shining matter, the stars and the gas and so on, then the galaxy would fly apart like an exploding flywheel. So there's obviously a lot of dark matter that's tugging on these stars out on the periphery of the galaxy, and by similar reasoning there clearly is a lot of matter between the galaxies, because we think that the disc-shaped Milky Way is embedded in a sort of gigantic spherical halo of stars and this dark material, whatever it is. And there's been good evidence, in fact, from observations performed at Mount Stromlo Observatory here in Australia, that some of these this dark matter is in the form of dim stars way out on the edge of our galaxy. But almost certainly that's not all that there is.
Paul, if there's some dispute about the date of the detonation, about the birth date, is there also disputation about the use-by date, about the end of time?
Yes, very much so. There are two different possibilities that I'll just briefly outline. One is that the universe is just going to go on expanding forever and ever, but at a diminishing rate. And the other is that it'll reach some state of maximum distension, after which the galaxies will start moving back together again. The whole universe will start to contract. That won't happen overnight. It'll begin slowly and then gather pace faster and faster until the entire cosmos obliterates itself at a big crunch, which is a bit like the Big Bang in reverse. So we have these two possibilities, but which of the two will come about depends on exactly how much dark matter there is in the universe. So I think
there was briefly a fashionable idea, which I must say I was very attracted to, which had an oscillating universe, if you like, an infinite succession and regression of big bangs occurring.
Bangs and crunches and bangs and crunches, yes, oscillating or pulsating model of the universe. That's never appealed to me very much, because it seems to me that it doesn't really solve any problems. If the universe has been cycling along like that for ever and ever, then it means that it has always existed. And of course you don't explain something by supposing it's always been there. But there's a more serious problem, which is that if the universe has processes, physical processes, that proceed at a finite rate, and there are many of these processes around us, and these are irreversible processes, then the entire universe would have reached its final state by now. It can't have been here forever. So we know there must have been a beginning. And this oscillating or pulsating universe really suffers from that problem. Sometimes people say, well, you could have a universe that goes on oscillating forever if each individual cycle was somehow disconnected from the previous cycles. That is, if when the universe went crunch and that crunch bounced into a new Big Bang, matter and energy were totally reprocessed, so no memory of the previous
that's why I found it satisfying.
phase would survive. The problem about calling this an oscillating universe is that if nothing from this phase of the universe survives into the next one, there's no particular reason to regard the next cycle of expansion and contraction as this universe doing something in the future. If no information can get through, what meaning has it got to say that this is a sequential thing? you might just as well say that the other cycles of expansion and contraction are in parallel to ours. It's a little bit like talking about reincarnation, but saying that no memory of your previous life will ever survive. What does it mean to say that you're the reincarnation of Napoleon rather than me? It's a meaningless concept.
I told you that in confidence.
So I think this idea of a cyclic universe, whilst it has a certain appeal and is sort of vaguely reminiscent of these Hindu cosmic cycles, doesn't make a lot of sense either philosophically or physically. And I think we have to accept that the two alternatives that are on offer are either that the universe is going to go on expanding forever and ever, but degenerating, or it is going to reach a state of maximum expansion and then collapse to a big crunch, and that's the end of the story. It's one or the other.
But which? And will we ever know? I've long been puzzled why so many of us dwell on the problem of the creation of the universe while scarcely sparing a thought for the manner of its demise. The next big question we'll consider is the nature of complexity. How can something as complicated as living organisms arise in a universe that starts out as a white-hot soup of subatomic particles? And what's the destiny of intelligent beings in a universe whose fate is already determined by physical forces? And where does the picture go when you turn off the telly?